What's up, breadwinners? It's Miss Sorensen with video 29, Expected Value and Fairness. I find this topic to be really interesting, and I hope you do as well. All right, so expected value and fairness. A few questions for you. Which one seems to be a better situation and why? You are at the Manson football game, and half of the fans buy a ticket. Each ticket costs $2, and if you win, you get $10,000. Now you're at the Seattle Seahawks game. You buy a raffle ticket for $5. Half of the crowd buys a ticket as well. If you win, the winner gets $8,000. Yahoo! Which one to you seems like it has a better value or seems fair to you? Well, what's important here? The amount that you win, right? Here you win 10,000, here you win 8,000. So it looks like we've got a vote for this one being better so far. The probability of winning, well, if half the fans buy a ticket in Manson, that's probably what? I don't know, if there's 300 people, you get one ticket out of 150. Versus here, there's a 40,000 person stadium, and you're one of that 40,000. So again, you're much more likely to win this one. So the probability of winning is a lot better for Manson football game. And how much you pay for a ticket. Okay, here you pay $2 for a ticket, but here you buy $5 tickets. So this one's also better. So these three things really kind of combine together to prove that the first situation here, not this first situation, is a much better and fairer situation for you. You've got a much better expected value. So what's important? The probability of winning, the amount you pay for a ticket, and the amount you win. We're going to call that the value. Here's the informal definition. Buys lottery ticket, wins more than lottery ticket value. Yeah. Although honestly, I've never really bought a lottery ticket except for gifts for family members. There's a reason they're out there. It's because you usually lose. But anyway, expected value, informal definition. How much you can expect to win given your investment. It depends on the likelihood of winning, the probability, and the payout, the value. Here's our formal definition, and you should get that down. Let's talk about what these things mean. This symbol right here means the summation or the sum. V stands for the value, which we know what that means now. P stands for the probability, and obviously the amount paid stands for the amount paid. So let's look at this formula here and kind of see where everything is. So the amount that you win, the value is represented in the formula right here. And then you've got the probability of winning is represented by P right here. And then how much you paid for the ticket right here is located here in your formula. And so everything has been accounted for. All right, should we go ahead and do a problem just to make this a little bit more realistic? I think so. All right, Miss Sorensen is having a raffle to promote cat cuteness awareness. She sells 50,000 tickets to old ladies. They really are the ones that are most willing to buy those tickets. The first prize is $1 million of cat food. The second prize is $300,000 worth of cat toys. And the third prize is $20,000 worth of cats. There are 7 fourth-place prizes worth $5,000 each. And this is for cat hair removal supplies. If you buy one ticket, what is your expected value? And just before we solve this problem, I think it's really important what we read from Fred down below. It says, Fred, are you sure about this? Yes, I'm sure. There's a 40-year-old unmarried woman living over there. She will treat us like gods. Ain't that the truth, Fred? Ain't that the truth? Anyway, let's go ahead and see what the setup of this problem is like. You probably shouldn't be able to solve this right away, but after seeing these, I think you'll do pretty well. All right. What you're going to do is you're going to make 3 columns. You're going to make a value column, you're going to make a probability column, and a V times P Remember, your formula is the sum of V times P, and then we're going to subtract that amount paid. What does the value stand for again? That's the amount that you win, right? And there's several cases here. Here, the first place prize wins $1 million. The second place prize wins $300,000. The third place prize wins $20,000. And then the fourth place prize wins $5,000. So that's what you're going to write down the V column. For the P column, you really care about the number of tickets sold. That helps you with your probability. There were 50,000 tickets sold. And if there's only one winner to win the $1 million, that's going to be an odds of 1 in 50,000. Now, I want you to assume that after someone wins something, they're going to put their ticket back in. So again, for second place, if there's only one person winning that, you've got a chance in 1 in 50,000. For the third place prize, you have a chance in 1 in 50,000. Now, a little bit different here is the fact that there are 7 fourth place prizes, meaning there's going to be 7 tickets that win out of the 50,000. So in this case, our probability is 7 over 50,000. Now, if you look at your formula, you notice that you've got V times P. And when you're multiplying fractions, you can think of this, and I'm just going to do one right here, as 1,000,000 over 1 times 1 over 50,000. And what happens is you multiply across the numerators and you get 1,000,000, and then you multiply across the denominators and you get 50,000. So that's how we're going to multiply all the way across here, and we do that for every single one. And this is the only one that looks kind of different because we're doing 5,000 times 7 is 35,000 divided by that 50,000. Okay, now the other thing in the formula that you see is the summation tool, which means we sum up, we add up all the V times P. So how do we add fractions? Well, we have to have a common denominator. Well, sweet, we actually already do. So I'm going to write my common denominator, and then I'm going to add up all of these values, and I get this number right here. And I'm just going to quickly do that division, and I get $27.10. Now, remember back at our formula here, sorry, one second. We have to take what we just found, and we now have to subtract the amount that we paid for the ticket. So let's go ahead and do that. So I'm going to subtract $100 because remember, we pay $100 for this ticket. Did I say that in there? Looks like I didn't, but I should have, and I promise I'll do that on the other ones. So if we pay $100 for the ticket for our raffle, our expected value is negative $72.90. In other words, we should expect to lose about $72 or about $73 on buying a ticket for this raffle. So do we want a negative number or a positive number for our expected value? Well, obviously we want a positive number, but is anyone in the world going to do a raffle where the expected value is positive? Well, certainly not, because they're going to lose money on that. Okay. The question says, determine the cost of the ticket that would make the raffle fair. A fair raffle would mean that you wouldn't lose any money and the person doing the raffle wouldn't lose any money either. So a fair amount would be actually the equal to your expected value, would be $27.10, because you wouldn't be expected to lose anything by buying this raffle ticket. That would be fair. However, would the raffle make any sense at all? Would it make any money? The answer is no, it wouldn't make any money at all. So yes, $27.10 is fair, but it's a little silly because the raffle won't make any money. All right, let's try another one here. You've got Brenda and Ryan are doing a raffle to raise money for their softball team. They are able to sell 4,000 tickets sold at $10 each. The grand prize is $5,000. The second prize is $2,500, and the third prize is $1,000. There are 5 fourth place prizes worth $200 each. If you buy one ticket, what's your expected value? Go ahead and pause the video and see if you could figure this one out on your own. Okay, hopefully you're back. Let's check your answers with mine. Okay. So you should have put your value. This is your first place, second place, third place, fourth place. Then the probability is going to be, because there are 4,000 tickets sold, 1 out of 4,000, 1 out of 4,000, 1 out of 4,000. However, there are 5 fourth place finishes, so 5 tickets out of the 4,000 win. So that's why that's there. Then we do multiplying across. Okay, and we multiply across, we get the following. And then we're going to add down, and we're going to keep our common denominator, that's 4,000, but we add up our numerators here, and we get 9,500. Okay, adding those up, 9,500 divided by 4,000 actually gives us $2.38. We have to subtract the number or the value of each ticket sold, the amount that you paid. So we paid $10 each, so subtract 10, and your expected value is that you're going to lose $7.62. All right, Nate's doing a raffle to help him get into the dart throwing college. His math teacher says he shows promise. How much should he sell his raffle ticket for to make the raffle fair? Is this smart for him to make the raffle fair? So there's 500 tickets sold. First place is 200, second place is 100, and there's 5 third place winners at $50. Again, pause this video, see if you can get this answer. All right, ladies and gentlemen, hope you're back. So the value of first place is 500, value of second place is 100, value of third place is $50. Probability of winning first place is 1 ticket out of 500. Probability of second place, 1 out of 500. Since there are 5 winners for third place, the probability of winning is 5 out of 500. Then we multiply straight across, and we get these fractions right here. Then we add, keep our common denominator, add our numerators, and we're left with 850 divided by 500, which is $1.70. So how much should he sell his raffle ticket for to make the raffle fair? Well, he should sell it for $1.70 to make it fair. The second question says, is it smart for him to make the raffle fair? No, it's not smart. He wouldn't make money. He wouldn't make bread, aka big dollar signs. So even though it would be fair, it just doesn't make any sense because you're not going to make any money. That's it, folks. I hope you enjoyed that topic. I do think it's a cool one. Thanks for showing up. Thanks for being you.